The next question is the output y of n of a discrete time system for an input x of n is y of n is equal to maximum of mod of x of k, where k is between minus infinity and n. So this is the input-output relation. Input-output relation of a discrete time system. Okay, the question is the unit impulse response of the system is the unit impulse response. What is actually unit impulse response? Impulse response is the response or output of a system to a unit impulse input. Okay, impulse response means impulse response means it is denoted by h of n. It is given by the output of a system for input del of n. Input del of n. Okay, so we are giving del of n, impulse as the input, and whatever be the output, we call it or we name it as impulse response, h of n. So we have to find out the impulse response of this system. Okay, so how will you find out the impulse response of the system? That will be, we can call it as h of n. H of n is equal to maximum of mod of del of k. Okay, the input is del of k, right? For k is defined as a value between minus infinity and n. Okay, so now analyze this equation. What is actually del of n? Del of n is actually a signal which is present only at n equal to 0. This is n equal to 0. This is del of n. Okay, this is a discrete time signal, so its amplitude is 1. Okay, discrete time signal, so its amplitude is 1. This is del of n. Okay, so maximum value of del of n will be always 1. Okay, right now h of n is defined as, you can see, maximum of del of k for minus infinity less than k less than n. So I'm considering um, my n somewhere here. Okay, so this is my n, right? So k will be somewhere here, right? Minus infinity less than k less than n means k will be between minus infinity, this is minus infinity, and n. So now what is the value of maximum value of del of k? Is 0, because del of n will be, or del of n will be present only at n equal to 0. So if you are choosing n here, n is less than 0, then k will be somewhere here, so del of k will be 0. Okay, so I can write h of n is equal to 0 for n less than 0. I can take this n anywhere less than 0. Okay, suppose I am shifting this n to somewhere here, then also k will be somewhere here. Okay, k will be less than, this is my new n, so k will be anywhere in this axis less than n and less than minus infinity. So still del of n is not coming here in this interval, so h of n will be equal to 0 for n less than 0. Now I'm taking my n somewhere here, my new n value is somewhere here, so k can be anywhere in this axis, right? Suppose k is here, right? Now what is the maximum value of del of k? It is 1, right? It is 1. And now if I'm taking n here, this n greater than 0, then again maximum value of del of k is 1, because in this interval this value n equal to 0 is coming, so maximum value will be 1. Okay, so for any n greater than 0, the maximum value will be 1. All right, so this is the impulse response. And are you familiar with this signal? This is nothing but, this is nothing but a signal with all negative amplitudes are 0, discrete time signal with negative amplitudes are 0, and positive amplitudes are 1. This is nothing but U of n, unit step signal. This is a unit step signal. So in this input output relation or the system, discrete time system, the unit impulse response will be nothing but unit step signal itself. So the answer is going to be option A.